Hello, 30-3s, and welcome to the third day or third lesson of transformations. Today we're going to talk reflections, but let's very quickly summarize what we know. What we know is we are taking some object in a transformation, and we can call that triangle or rectangle x, y, z, q. And what happens is we transform it somehow into an image. And how do we know what we started with and what we finished with? Well, remember our starting object after the transformation of some kind, whatever that transformation is, becomes the image. And we know it's an image because of the little ticks, which are referred to as prime. So y, x, z, q becomes y prime, x prime, z prime, q prime after a transformation. What kind of transformations are there? Well, we started with translations, which, if you recall, is just to move to a new point, to a new position. Move to a new position. And what's important with that is our x, y, z, q, when it transforms to x prime, y prime, z prime, q prime, these two items in a translation are congruent. They don't change. They change where they are, but they don't change how they look. The second translation we did was a dilation. Now, a dilation is where we change the size of the original object. And we change it by multiplying everything by the k value. So what's important there is if I had x, y, z, q, and it transformed through a dilation, which I would then call double prime, because single prime was the translation, the dilation takes it, and the objects are now similar. Remember, because we changed the shape of them, and let's see if I can do that up here. It's not going to let me. The whole thing. Anyways, we changed the shape. So we took x, y, z, q, and what happens, remember, is we were able to make it all bigger, or we could take it and make the whole thing smaller. That's a dilation. So the object isn't congruent anymore. It's similar. Angles are the same, but the object is a different size. So those are the two we did. Today, nice little quick one, a reflection, which is where we flip things. Now, there's a couple key points with reflection first. First of all, a reflection is flipped over a specific line, which is referred to as a line of reflection. A line of reflection has to be identified. You have to know what the line of reflection is in order to do a reflection. Once we know what the line of reflection is, why it's so important is because every point on the object becomes equidistant from its image point. So not only do things flip over a line, but they flip and then everything is the same distance. So this first diagram here on the left with the orange arrows, the line of reflection in this case, we see it's a vertical line of reflection. And so that means if I were to pick this point, which I'm going to call A, well, what I would need to do in order to do a reflection is identify how far A is from my line of reflection. And then I would need to take that distance, which I can do on my smartboard, and when I move that distance, it's the same distance. So everything, A prime, is now equidistant. So each of these distances, I could put ticks on those to say those distances are the same. If I pick this point here and called it W, Well, again, W is a certain distance from our line of reflection. Well, when we have that reflection, we get the exact same distance to the image. So there's W prime. So W is so far away from the line of reflection, and W prime is that same distance on the other side. So that's why the line of reflection is so important. Yes, we're flipping over it, but it has to be equidistant. And when we do that by flipping, we see all of a sudden that in our diagram, the left side, which is furthest from the line of reflection, all of a sudden it reflects, and it's now the right side of the second object. So this is referred to anytime you do a reflection, it becomes a mirror image, because left side all of a sudden becomes the right side. The left side of the arrow is now the right side of the arrow. Just like if we have over in this other one, we have a horizontal line of reflection. And in a horizontal line of reflection still, my point B is a certain distance from the line of reflection. Well, going to move the whole thing, which is okay. Well, I can see that I get the same distance. From the line of reflection, I get now B prime. So it's still that same idea. Distance from my object to the line of reflection is equal to the distance from the line of reflection to my image point. And why is this a mirror image? Well, because the top of my arrow after my reflection becomes the bottom. So mirror means everything switches around. So that's what we're looking at with a reflection. That's the key. It's not just to flip it, but to keep everything equidistant. Now, when we do a reflection, like I said earlier, line of reflection is the key. If we don't have a line of reflection, we can't do a reflection. So, line of reflection, these first 2 points. Line of reflection normally, most questions, if we take a look at this first Cartesian grid, there's our X and Y axis. A lot of times, a majority of times, you will reflect over the X axis or you will reflect over the Y axis. But understand it's not always that straightforward. Sometimes you get that line of reflection that's not the X or Y axis. Well, this first case, and then we'll take a look at the second scenario in a second, but we need to be able to identify where that is. When we take a look at this first line of reflection here, we see that it's 1, 2, 3, 4, 5 up, and up is Y. So our line of reflection in this case is saying we want where Y is equal to 5. So when we go up, there's 5. That's where we want the line of reflection at Y equal to 5. So then, whatever point I had there, what's essential? It's important that everything would be equidistant. I'm so far away from my line of reflection, so I would need to be so far away from my line of reflection. Point W becomes W prime. Next one, we see here, this line of reflection now, well, it's 1, 2, 3, 4 on the x-axis to the left. So left axis, or moving left, is on the x-axis, so we would want our line of reflection at x equals -4. 4 to the left, that's where the line of reflection would be, and that's what our object and image would have to be equidistant from. If you flip to the next page, well, here's 2. Very quickly, pause the video, put in the line of reflection, see what you come up with, and then we'll talk. So what we're looking at in this first one, it says the line of reflection is at x equal to 6. Well, we start at the origin, x equal positive 6 tells us to move 6 to the right. So there's where x equals 6. So there's where our line of reflection would be. Whatever we had for an object, that's the line of reflection we would want to flip over and have our object and image equidistant from. A line of reflection where y is equal to -2. Well, y is our vertical axis, so we would want to be 2 down. There's our origin. 2 down takes us there. So there's where we would want to have our line of reflection. Once you have your line of reflection, you could then do the necessary reflections. All right, so let's do a couple. Not overly complicated, I don't think, I hope, but let's see what it looks like. Here, we want to draw the mirror image after reflecting over the line. So we see, to start with, we want to reflect this R, and there's our line of reflection, so everything has to be equidistant. Now, the key, we don't have to reflect, every single point on that R technically has to reflect. Every one of those little points has to reflect. Do we have to reflect every single point? No. What would be key? Well, I hope you understand that if we reflect some of the key vertices, well, reflecting those key vertices are what will help us to then draw the image. So what are we here? We see that we're 1, 2, 3, 4 away. So 1, 2, 3, there's where our image has to go to. So we can draw that first part. Again, it doesn't matter how far apart these two are technically. What matters is, again, this point from the line of reflection is a 4 away again. So 1, 2, 3, 4. If that's 4, well, let's see, I can't move it. It's going to move everything, and I don't want it to. But we're 4 and 4 away, so we could then connect there. 2 more points. Here to there is 2 away from the line of reflection, so I want to go 2 away like that. Those points I can use then. So 2 away is to there. And how do we get from this point to that point? It's with the curve. So I can sketch that in. Obviously, on the line of reflection, nothing happens. On the line of reflection, nothing happens. But our last one is 2 away, so we're 2 away. And we can now finish. And there, actually even this, how far away is this one? 1, 2, 3.5. So 1, 2, 3.5. And then it drops to there. So we can see that we have the mirror image. Our R, actually, and I didn't do a great job of my bump in the R, we can see that it only goes to this line. So I would be consistent. And there you go. Maybe give E a try, pause the video, and then come back. So for E, not a lot different. Our points here, if it's 3 away, we need to be 3 away. 2 away, we need to be 2 away. So I can start to connect these. This point here is also 3 away. 3 away, so I know I want to reflect. My left side of the E will become the right side of the new E. And we can just keep working. Here we're 2 away, so we're 2 away. Here we're 1 away, so we're 1 away. And so on. 1 away, 1 away. This is not total rocket science. We need to finish with something that is a reflection of what we started with. And if it's a reflection equidistance away, we know we have done an appropriate reflection. So there we go. Now we can get to some, though. We want to reflect the triangle about the line y equals 1 and identify the vertex points. So, possibilities here. We need a line of reflection at y equals 1. Well, y axis, up and down, we want to be at y positive 1. So there's our line of reflection. There's the line of reflection we want because that's y equals 1 because it's 1 up on the y-axis. So now I need to reflect. That means this bottom point on my triangle, I'm not worried about the axis. I need to go to the line of reflection. There's my line of reflection. 1, 2, 3, 4, 5 away. So I need to be 1, 2, 3, 4. Look at that, we actually got to go off of the grid, but not totally impossible to do because we need both of those to be equidistant away. So my next part of the point on the triangle, 1, 2, 3 away from the line of reflection. So 1, 2, 3 away from the line of reflection takes me to that point there. And I can now connect those two. And finally, my third vertex, 1, 2, 3, 4, 5 away from the line of reflection. 1, 2, 3, 4, 5 away from the line of reflection. So there's my new triangle that's my image. So that's how we can work with reflection about a line that's not the x or y axis. Understand how to draw those in. But it did ask for what are the vertex points? Well, I'm just going to call it vertex 1, 2, 3. So what's 1 finish at? When it wants to know where they are, well, now we're plotting from the origin. I don't care about the line of reflection when I want to identify the actual vertex points. How would I get to point 1? Well, first day we talked about how far are we going on the x-axis? We're going 1, 2, 3 left. And then we're having to go 1, 2, 3, 4, 5, 6 up. So point 1 is at negative 3, 6. Point 2 here, well, from the origin, we need to go 1, 2 left. And we need to go 1, 2, 3, 4 up. Plotting points, identifying points is from the origin, remember. And our third point from the origin, we're not going left or right, so it's 0, but we are going 1, 2, 3, 4, 5, 6 up. So there's the 3 points on my image, what I finished with. Now, hopefully that isn't too difficult. The only thing I want to point out here, and I know that's not what the question says, is that a lot of time a question will state reflect over, and it'll give you one of the axes. So let's say we're reflecting over the, I don't know, let's say the y-axis. If we reflect over the y-axis, well, that means the y-axis is our line of reflection. Sometimes it's going to be a unique point. Sometimes it's as simple as an axis. So if I reflect it over the axis, what's nice with this one is that 1 point doesn't change. If I reflect, it's still the same. However, we're 3 away, so we need to be 3 away. We're 2 away, so we need to be 2 away. And there's the image if I reflect it over the y-axis. So line of reflection, understanding what it is the key to all of these questions. Don't think it's too complicated, I hope. Finish, please, the booklet, page 13 and 14, the reflections assignment section. I think there's only 2 questions in there. Please remember, in the Google Class, there is a supplemental pages document. Please work on page 5 and 6. Just doing 1 to 3 on page 5 and 1 to 3 on page 6. So a few extra questions. Please don't forget, if it's necessary, there are Cartesian grids for you to print off and use if you need them, but a lot of times these questions will have the grids with them. Not overly complicated. Stay on top of it. Rotations next lesson. A little tricky, manageable. So we'll see you next lesson.